Welcome back, everyone. Let's get started by learning how to use a convolutional neural network on custom images, essentially your own PNG or JPEG files. In part one of these series of lectures, we're going to focus on just understanding what our data looks like and how to set the file paths for our data. Let's get started. All right, in the previous lecture, we imported OS, set up our data directory, and upon calling the list directory from the data directory, you should have seen that there's a test folder and a train folder. So what we're going to do after this is we're going to explore this further, but first I'm going to copy and paste a couple of imports from our notebook. The first being pandas as PD, numpy as np, seaborn as sns, and then matplotlib.pyplot as plt. Now we've already seen all those imports before, but there's a new one that we're going to use to actually read in real image files, and it's called from matplotlib, so from matplotlib.image, not .pyplot, go ahead and import imread. So this is going to allow us to read in image files directly. So we already know that we have a test set and a training set inside of this. Let's go ahead and set two variables. We'll call one the test path, which is my data directory, and then I'm just going to concatenate as a string, and I'm using double backslashes here because I'm on Windows. And I'm going to add in that test directory. And then I'll create a training path and state that my data directory plus, and in this case, again, double backslashes here on test train. And whoops, it's going to be data directory, not my data directory. Okay, perfect. So if we take a look at test path then, and run Shift Enter, it's essentially the file path to the test set. So let's go ahead and list what files are inside by saying os.listDirectory, and we'll go ahead and pass in our test path. Run that, and you'll notice there's parasite versus uninfected. And basically what we're looking at here is a data set that contains two folders. Originally, it contains an infected folder and an uninfected folder. This has already been split up in test train for you. And it contains a total of about 27,000 images. And this data set is taken from a government repository on malaria datasets. So there's a National Library of Medicine, and the link is in the notebook for you, in the notebook that goes along with this lecture. But you can check out the full publication, and the datasets here, they have it as cellsimages.zip. It's available from NIH, so you can check out the full details here, but essentially, it's just images of whether or not a cell has been infected with malaria. So we're going to come back here and notice we have essentially a subfolder underneath test for images where the cell has been infected and one for where it's not infected. And we can do the same for the training path, and it's going to have essentially the same set of categories. So what we're going to end up doing is attempting to build a model that just based off the image of a cell, can it predict whether or not it's infected or not infected. In theory, this could hopefully save real doctors a lot of time by just running images into our model instead of having to manually look at these images themselves and determine it. So what we're going to do is just take a look at a single image. So we're going to say OS list directory, and let's go ahead and do the following. We'll say from our training path, go ahead and concatenate we'll look at one that has the parasite. So we'll say plus that, run it, and you'll see a list of all the image files. So here's one PNG file, cell 162, 163, and so on. So there's thousands of images here. Let's go ahead and basically this function just listed all the images. Let's just grab the first one in this list. So if you notice here, I now have this PNG file, and what I need to do is basically tell the image read function where this file actually is. So this parasite cell or infected cell, I'll say paracell is equal to, and we'll say train path plus parasitize there, plus, and then to make sure everything works, we'll add two sets of backslashes there. There should essentially be slashes between all the file names, or all the directories, and then add that there. So if I take a look at Paracel just individually after running this, all I'm trying to say is that this Paracel is essentially the entire file path to a single image, which means I can then use the image read function that we imported. So go ahead and imread Paracel, and it automatically transforms a PNG file into an array for you. And if we check out the shape of this, you'll notice that this particular image is 148 by 142 by 3, which means it's a color image. Let's go ahead and explore what it actually looks like. So we'll say PLT, and now I can say image show on this image read call, run that, and this is what a cell looks like when it has the infection, the parasite. And you can see there's this little dark infected, essentially, area. Let's go ahead and do the same for an uninfected cell and see what it looks like. So I'll say my uninfected cell is equal to, and in this case we'll say train path plus, and we also need to say uninfected backslash backslash, and I need to grab just one single image from this. So I'll use the same approach as we did last time. We'll say OS list directory, and inside the training path, go ahead and grab from uninfected. So I can just say grab from uninfected here, pass that in, and let me split this up so you can see what this returns. So recall, whoops, uninfected should have an N there. Go ahead and run that. That lists all the image files inside the uninfected folder inside my training path. Just grab one of them, and now we have that name right there. So grab that, or just grab this and then paste it. So you can either do that or just grab the raw string itself. Either way, it doesn't matter. It's going to be the same code, essentially the same string. And so now we have the file path to an uninfected cell. So that's the complete file path to an uninfected cell. Let's go ahead and read it in. So I'll say my uninfected cell is equal to image read, and then we'll say uninfected cell. And now my uninfected cell is that array. Call PLT image show here. And this is an uninfected healthy cell. The difference should be quite obvious. Notice there's kind of a dark indication here of the infection, and the uninfected look essentially quote unquote normal. They're just kind of this pink. They don't have this dark stain. Okay, so a big part of this is just understanding the file paths on your computer. And you can always understand the file paths as we discussed in the Panda section. If you type pwd, that lists the current location where you're at on your computer inside this notebook. Okay, so let's go ahead and check how many images there are. Lots of different ways we can do this, but one way is we can say os.listDirectory, get our training path, and then let's go ahead and check out how many parasite versions do we have. And then also constantly make sure to check your spelling here, and then check the length of this. So it looks like inside the training folder, we have 12,480 examples of infected cells or parasitized cells. And then the length here, we'll say list directory, again on the training path, except this time let's look at uninfected. So we'll say uninfected, check the length there, so it's the same amount. So we have the same amount of images as uninfected versus parasite cells inside our training paths. And we could take the same look for our test paths. So there's 1,300 images of parasite cells under the test set. And if we take a look at the test set as well, there's 1,300 uninfected. Okay, so we have the same amount of instances per class, which is nice. So we can go ahead and comment these out now. And let's go ahead and finally figure out the average shape of one of these images. Something to note here is since these are real image files, it's unlikely that they're all going to be the exact same shape. Previously, we didn't have to worry about that because we were reading in datasets like the MNIST dataset, the Safari 10 dataset, and every image happened to be the same dimensions. Real life images are not going to be that way. They're going to have different dimensions. So, lots of different ways we can do this, but one way is to set up two lists, call one dim1 for dimensions, and the other one dim2. So dimensions 1 and 2, and what I'm going to do is the following command. I'll say for image file name in, and I'm just going to look at, let's say, our test images. We'll say in OS, list directory, underneath the test path, take a look at the uninfected. So grab those uninfected images, and then go ahead and read in that file as an array. Say image is equal to image read, and in this case we'll say the test path plus uninfected, make sure you spell that right, \\, plus the actual image file name. So recall os.listDirectory test path uninfected. If I take a look at what that returns, essentially what am I actually iterating through? I'm iterating through each of these files. So go ahead and grab that file, but in order to actually do the image read, I need to pass in the full file name. Okay, that allows this cell to run from any directory no matter where you're located on your computer. So I'm reading in all these files, so I'm reading in all these images, and then what I'm going to do is I will check the image shape. Recall that the image shape is a tuple of 3 dimensions. It's dimension 1, dimension 2, so width and height, and then the colors dimension, which is going to be 3 for all of them. There's 3 color channels for all of them. So now all I'm going to do is say dimensions 1, append the D1 value, and dimensions 2, append D2 value. Make sure, get rid of that S there. So all I'm doing is I'm iterating through every file in, by chance, the test path uninfected. So that is going to be 1,300 files. Then I'm going to check the shape of each of them and then save their first dimension and their second dimension. Let's go ahead and run this. Keep in mind that you should triple check the file paths here and make sure everything is correct. And after that, you should be able to check one of these, and it has a bunch of dimensions in it. Notice they're all different. So these are real image files, which means they're not all going to be the same dimensions. They're not all the same shape. Same for dimensions 2. And to see basically a histogram of both, we can say SNS joint plot, dimension 1, dimension 2, and we get something that looks like this. So I can see the various dimensions. We have a really small image that's like 50 by 60, and a really large image over here that's around 200 by 200. Okay, so why is this important? Well, the convolutional neural network isn't going to be able to train on images of various sizes. So what I need to do is I need to make sure that I'm going to resize all these images to be the same size. So I have to choose what actual dimension should I resize everything to. And what you should choose is essentially the average of both dimensions. And this shows you the actual distribution of the images. And they all kind of center around basically 130 by 130. And you can confirm this by checking out the mean values in your dimensions. So we can say the mean of dim1 and the mean of dim2. So what I'm going to do is I will say my final image shape that I will be feeding in my convolutional neural network is 130 by 130 by 3. Go ahead and run that. And then later on, when we're actually preparing the data for the model, I'll resize everything to these dimensions. So if it's a smaller photo, I basically can add padding so that it reaches these dimensions. And if it's a larger photo, I can either crop or shrink it down. Okay, so a big part of this lecture is understanding file paths. Please make sure to review the input and output lectures in Pandas if you're still confused on file paths on your computer. And again, please keep in mind if you're posting questions about your file paths is that I won't have access to your computer, so I can't really see where you're saving your files. What you should be able to do is once you actually set up this line of data directory, you should be able to run our notebooks and everything should work. The only thing you really need to edit is this singular line right here. Again, yours isn't going to be the same as mine because you're not on my computer. All right, so a lot of file paths here and being able to read in real image data. That's all we need to cover for this lecture. Coming up next, we're going to show you how to use the image data generator to both perform image manipulation and then generate batches from real image files. I'll see you there.